greatest common factor. When we are looking at trying to think about the greatest common factor, where would you use information dealing with the greatest common factor? Not to be confused with least common multiple.
When you're simplifying equations.
Simplifying equations, possibly. Fractions, possibly. Can you think of any other time? The way we are going to use the greatest common factor is in a process of factoring. It's called factoring. We want to take something out. So if we look at what the greatest common factors are, we have algebraic factors. Algebraic factors involve two things. The two things they involve, we have numerical factors, which are going to be what? What do you think? Numbers. And we have literal factors, which are going to be variables. The letters are the variables. We want to come up with the greatest one between two terms. So the greatest common factor is the product of all prime algebraic factors that has to be common to every single term, each to the highest power that it occurs in all of the terms. So what we want to do is we want to be able to look at this. Caleb, is that? So for an example, if we look at this, part of the reason you do prime factorization, if you were to look at this trinomial here, because you have three terms. The first term, if I break that down into prime factorization, it's 2 times 3, then you have x squared, which is 2 x's. Y squared means you have 2 y's, and m squared means you have 2 m's. If I look at the next term, it's 3. You have an x, you have 3 y's, and you have 2 m's. And then the last one, you have 3 x cubed and y squared. The greatest common factor that we have is that it has to occur, it's common to every term and to the highest power that it occurs in all the terms. The most, not the highest power in one of them, the highest power in all three of them. So what you do to figure out what is that greatest common factor is what is something they all have? A 3. So we have a 3. The highest power in all three of those is just to the first. What else do we have? We have 1x. I don't have 2 because I don't have 2 here. I don't have 3. So the most x's you have is 1. What about the y's? You have 2 y's in both of them. Do you have any m's? No, because it has to be in every single term, and I don't have any m's in the blue term. So the greatest common factor for this, the greatest common factor is going to be 3 to the first, x to the first, y to the second, which you're just going to show as 3xy squared. That's the greatest common factor. What we want to be able to do in between this lesson and the next lesson is factor that out of here. For example, this is what you're going to work on for the next lesson, is we factor that out, and then you put what you would multiply by to get back to this right here. So what you want to put in the next lesson, we're going to be talking about it, is coming up with what is left after you take out the greatest common factor. If you use the distributive property, 3 times 2 is 6. X times x is x squared. You have your y squared and you have your m squared. First term. The next thing, ym squared. 3 times 1 is 3. You have an x. Y squared times y is y cubed. And you have m squared. The last term, 3 times 1 is 3. X times x squared is x cubed. And y squared gives you y squared. This is a factored form. Factoring plays a big role when trying to simplify equations, simplify fractions, anything like that. If you want to know how you get what's in parentheses, it's everything down here that's not highlighted. I highlighted the 3, but not the 2. I have an x, and I have m squared. In the second term, I have a ym squared. In the third term, I'm just left with the x squared. That's how you get the factored form. But the greatest common factor is just what is in every single term. So we look at an example. Find the greatest common factor of this. What's a common factor between 8 and 12? 4. Is that the greatest one you can have? Yes. So the greatest common factor is 4. Do you have a z in both one? Yeah. In both terms, you have a z. What power would I have? To the third power. Do I have an m in both terms? Yes. So I have m to the second, and I have a p in both terms. It's going to be p to the first. That's your greatest common factor. That's what they're looking for just this particular lesson. I usually do not have students just answer or do some of these. I have them go straight into the factoring. If they ask you to factor it, you would have a 4z cubed m squared p. Do you know what you would be left with? 2. You have a z to the first. If you multiply these two together, do you get that right there? Yeah. 4 times 2 is 8. Z cubed times z is z to the fourth, m squared p. All right. Minus 4 times what is 12? 3. You have all the z cubes are brought out. M to the second, that's going to make it m to the fourth, right? When you multiply, you add the exponents. And what about the p's? You have p to the first left. This is the factored form, and that's what they're trying to get you to. The first thing they want you to recognize, though, is what you factor out. Then they worry about what you put, what's left. So we go to this one. Now, that one I didn't line them up and highlight. I did not line them up and highlight. You can. That's still going to get you there. Some of you can do it without it. Some of you are going to need the highlighting. If you look at 4, do you want me to highlight? 4 is 2 times 2. X squared is 2 x's. You have y to the third, and you have z. 8 is what? 2 times 2 times 2. Then you have x, you have y squared, and you have z to the third. Can you see what the greatest common factor is going to be? The greatest common factor is going to be a pair of 2's, an x, a pair of y's, and a z. So your greatest common factor I don't know. You have 2 times 2. What's this what? 4. Oh, look here in just a second. Oops. So you have 4x, y to the second power, and z. If I ask you to factor, it would be 4x, y squared, z, and what goes in parentheses. What you're left with. In the top one, what is not highlighted? X and y. In the bottom equation, there's a minus sign. In the bottom equation, what are you left with? 2z squared. There's the factored form. Greatest common factor, right here. Right here is the factored form. And then what? 2 x's. So 4 is 2 times 2, 3 x's, 2 y's, 1 p. The next one is 2 x squared, y squared. Really? P, 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 and how many more of them? Yeah. That work? All right. What is the greatest common factor? 2 to the first. x squared, y to the first and p to the first. So you look at it and you say, what goes into 2, 4, and 16? Just a 2, right? You want to go with the, if there's an x in every single one, you go with the smallest power. What is that? X squared. That's where we get this right here. We have y to the first. Well, there's a y in every single term, which has to be. If it only occurs in 2 of them, you can't factor it out. And the smallest power of y is to the first, which is what we got in our highlighting, and p to what power? The first. The smallest one is right there. There's your greatest common factor. If I asked you to factor it, it would be 2x squared yp, and what would you be left with? 8 p squared minus 2 xy, and then that sign, so I have plus, the 2's out, the x out, y p to the 14. There's your factored form. Factored before or new? Still recording. I don't know, I just heard part of what you said.